Hi there, students. We're going to be getting ready for topic 6. So the first thing I'd like for you to do is to complete the review what you know. This is page 329. It is the first page of topic 6, and come back and check your answers and be ready to move on to lesson 1 in just a few minutes. All right, first go ahead and check your vocabulary and then pause the video as soon as you're ready to try 5, 6, and 7 and come back and check your answers to those questions. All right, so take a look at numbers 5, 6, and 7. These are one-step equations. You should have learned how to do this last year in 6th grade. Remember that solving a one-step equation involves inverse operations. So as you are looking at the equation, determine what operation is involved, and you're going to use its inverse operation to undo it. So in number 5, you have addition, which means you undo addition by subtraction. In number 6, you have multiplication, so you undo multiplication by division. And in number 7, you have a special case where it's multiplication by a fraction. So instead of dividing by that fraction, you're actually going to multiply by its reciprocal. You might remember that from before. And in order to simplify that, you would multiply both parts of that equation by 3 in order to get your value for x. So check your answers on 5, 6, and 7. And when you're ready, move on to 8, 9, and 10. All right, go ahead and take a look at your answers for numbers 8, 9, and 10. I apologize, number 8 took quite a bit of space there, so it kind of runs over and it looks like it's involved in number 9, but it's not. You have 3 answers there, so check your answers and check my work. If you're unsure how I got something, please let me know. And when you're ready, try number 11. All right, for number 11, since we're writing an inequality, we need to define the variable, or the part that we don't know. In this case, a large box of golf balls has more than 12 balls. We don't know exactly how many are in that box, but we do know that the large box has more than 12. So we're going to let a capital letter B equal the large box of golf balls. So that's going to be the variable that we use to stand for that. Then we have to select our inequality sign, and that inequality sign needs to represent a situation that indicates more than. Well, you have 2 choices. You have the greater than symbol, and you have the greater than or equal to symbol. And the difference between them is, in the greater than symbol, the number is not included. So in this case, we are not including 12 as one of our answers, or possible answers, because it doesn't say a large box of golf balls contains 12 or more. It says the large box of golf balls contains more than 12. If we were to use the second symbol, the greater than or equal, then that means the number is included. So in this case, because 12 is not included as one of our answers, then we use the greater than symbol, not greater than or equal to. All right, go ahead and flip and take a look at lesson 6-1 and continue your work and notes there. All right, we're now on page 331, and our focus in lesson 6-1 is on writing 2-step equations. So we're going to be working with problems and how we can translate those problems into a 2-step equation. So let's take a look at the Explore It problem, because this continues over into example 1. It says Marley collects golf balls. His neighbor Tucker collects 3 more than twice as many golf balls as Marley. So in this kind of a problem, what we're looking at doing is determining how can we represent the number of golf balls in Marley's collection and the number of golf balls in Tucker's collection. In both cases, we don't know how many golf balls are in the collection. So Marley is going to be using the letter M to represent the number of golf balls in his collection. Now let's take a look at Tucker's collection. The problem specifically tells us that Tucker collects 3 more than twice as many golf balls as Marley. So 3 more than would indicate add 3. And twice as many golf balls as Marley means to take Marley's number and multiply by 2. So this expression here represents the number of golf balls in Tucker's collection. Now we're going to take that information and continue in example 1. Now when we look at example 1, we still don't know the number of golf balls in Marley's collection. However, the problem now tells us that Tucker has 159 golf balls in his collection. That 159 represents, remember from our previous problem, 3 more than twice what Marley had in his collection. So a bar diagram can be used to represent the situation. Tucker's collection is the 159. This collection is equal to the golf balls in Marley's collection, which is twice Marley's plus 3 more. So the equation that we can use to represent this situation is 159 equals 2m plus 3. Now take a look at the try it. See if you can complete the try it and come back and check your answer. Alright, so check your answer to the try it. Notice that you have a fixed amount, which is called the down payment. Okay, that's a constant value. And then you have 6 monthly payments that are all equal. So we have 6 variable p in the bar diagram, and then when we write our equation, we need to multiply that variable p, that monthly payment amount, by 6 because that's how many payments are going to be made. Now let's take a look at example 2. Sometimes it's best if you can draw a picture or write out in words what's happening and then try to translate it into an equation. A baseball weighs 25 7/75 ounces less than a bat. Write an equation that represents the relationship between the weights of the baseball and a bat in terms of the weight of the box. So here we need to have the picture because the picture tells us that the box contains 50 bats and weighs W ounces. It also tells us that one baseball weighs 5 25 ounces. So let's take a look at the relationship here. The weight of one baseball, or 5 25 ounces, is equal to the weight of one bat subtracting their difference in weight. But we don't know how much one bat weighs until we take the weight of the box, okay, that's this piece here, and divide it by the number of bats in the box. So we get W divided by 50 is the actual weight of one of those bats. So once we know the weight of one bat, we can subtract the 25 75 ounces because it tells us that the baseball weighs that much less than the bat. And this equation would tell us here that relationship between the baseball bat and the baseball. Now let's look at completing the try it. This one we're actually going to do together, and it's easier if we draw a picture as we work. It says Marcia and Tamara are running a race. Marcia has run 4 kilometers. Tamara has completed 3/4 of the race and is 2 5/10 kilometers ahead of Marcia. Write an equation that represents the relationship between the distances each girl has run. Let K represent the total length of the race in kilometers. All right, so take a look at the little number line diagram that I drew here to represent Marcia and Tamara and where they are in this race. Marcia and Tamara are running a race. Marcia has run 4 kilometers, so you see that there on the number line. Tamara has completed 3/4 of the race, so that's why she's 3/4 along the way here. Yep, let me put that point back up there, right here. and is 2 5/10 kilometers ahead of Marcia. Write an equation that represents the relationship between the distances each girl has run. And again, we're going to let K represent the total length of the race in kilometers. So in this case, what we have here is we have Tamara's distance, which is the 3/4 of the race. And if we subtract from that the 2 5/10 kilometers that she is ahead of Marcia, then we actually get Marcia's distance, which in this case is 4 kilometers. So the equation 3/4 K, 3/4 of the distance of the race, minus the 2.5 kilometers that Tamara is ahead, equals the distance that Marcia has covered in the race, which is 4. So 3/4 K minus 2.5 equals 4. In the next example, we're going to be interpreting quantities and operations and equations. And this is pretty important because it does give us some clues where we might need to use grouping symbols as we're writing equations. Example 3 says Claire bought 8 tickets for a total cost of $104. She had used a coupon code to get $3 off of each ticket. Let X be the original cost of each ticket. Which of the following equations correctly represents the situation? Well, the first instinct is to do 8 tickets for a total cost of $104. So 8 times the cost of a ticket would be 104. The coupon code that she used was to get $3 off the cost of each ticket. So in other words, if I call X the cost of a ticket, I need to take away $3 from each of those before I multiply by 8, and then my answer should be $104 for the total cost of all those tickets. So when you look at these 3 options here that they've given you, in all cases, they show you the 104 as that total cost. So what we're really looking at here is what in these equations is telling us to do with the ticket price and the 8. Okay, in the first one, the $3 discount is not going to be multiplied times the difference of 8 tickets and the cost per ticket. That just doesn't even make sense. We would never take the ticket cost and subtract 8 if we're buying 8 tickets. In the second problem here, 8x minus 3 equals 104. Notice that you're multiplying 8 times the x, which is the cost of the ticket, but then you're only subtracting a total discount of $3. But that's not what the problem says. The problem says you get $3 off of each ticket. So what we need to do is we need to somehow group together the ticket price and take away the 3 from that, and then multiply by 8, which is exactly what they did in the third example here. So the 8 is going to be multiplied by the difference of the cost of a ticket and the $3. So we're going to first subtract the discount here, and then we're going to multiply by the 8 tickets that we need to get a total final cost of $104. So in this case, we need grouping symbols around the subtraction in order to know to do that step first in the problem. Now try the triad that goes with example 3 and come back and check your answer. All right, in this triad, notice that the hat is 60% off, which means Claire is actually paying 40% of that cost of the hat. And that's what we did in the last topic, where we subtracted that 60% discount from the original price, which is X, and you get 4/10 X, which is 40% of the price is what you end up paying. So when I take that 40% of the price plus the amount that you paid for the socks, or that she paid for the socks, $5.49, we get a total of $9.49, which is this second equation here in that list. In this lesson, there are a total of 17 questions. Decide which questions and how many you need to do in order to show that you have learned how to write a two-step equation. When you're ready, come back and start the video again, and you can check your answers to any of those 17 questions here in the practice and problem solving, the do you understand, and the do you know how. All right, here are your answers for 1 through 6. Pause the video, and when you're ready, go ahead and try the rest of them, 7 through 17, and we'll have answers for those on the next slides. All right, go ahead and check your answers for 7 through 11. We're going to go ahead and skip 12 and 13, and we will move on to the back side. So pause the video while you check your answers, and then when you're ready, go to the back side of your page, page 336, and try numbers 14 through 17. All right, go ahead and check your answers on numbers 14, 16, and part A of 17. I am skipping part B on that one, especially because your answers are likely going to be different than mine. If you have questions about how to do that, I'd be happy to address it. Writing a description of an equation and a real-world situation are not exactly the same thing. So when you write a description like you did in number 16, you're just describing the operations and what's happening in the equation. When you're doing a real-world situation, then you are responsible for making up the story behind that, and that is going to likely be different from student to student. If you have questions about this, let me know. Otherwise, I'd like for you to log into your Pearson Realize account, and you have a 6-1 exit ticket in order for you to complete. I believe there are only maybe 3 or 4 questions on there for 6-1, so try those, and then you are good to go for this lesson.